This is going to be the walkthrough of the homework questions on chapter 4, so you can get an idea as to where the answers come from. Most of the rest of these you can determine what the answer is because they're more concept questions than they are mathematical. But these up here, let me give you a brief idea as to where these are coming from. Here, what is the ratio between the apparent size and the actual size of the focal spot and tube with a target angle of 6 degrees? Now, this question actually comes from this part in the book. The actual focal spot size is S and the target angle is this. Then the apparent focal spot size, which is this, is related with this equation. So if you take the apparent focal spot size divided by the actual focal spot size, then what you would actually get would be little s divided by big S, which is equal to sine theta. The question here, let's get back to it. Question here is asking just that. What's the ratio between the apparent size and the actual size? So what you're actually needing here is little s divided by big S. So according to the book, what you need to figure out here is the sine of the angle that's given. In this case, it was 6 degrees. So if you go to the calculator, I type in 6, go to trigonometry, take the sine of it. So you can see here it's 105, which I believe that's what this is. So that is how you work the first question. Let's go to the second. What is the ratio between the apparent size and the actual size of the focal spot in the tube with a target angle of 17 degrees? Same process, you just type in a different number. Go up 0.292. That's where that comes from. For part 3, or question 3, what is the ratio here for the target angle of 30 degrees? Again, same process. For question 4, an X-ray technologist makes an exposure at 100 kVp, 100 mA, 0.5 seconds. The image darkness is acceptable, but the image is blurry because the patient is fidgeting. So you decide to make the reduce the time to 0.2 seconds to try to minimize that. If the KV is kept the same, what MA should be chosen to keep the image darkness the same? So again, if we go into the book, let's see if I can find the you can see here that there is a formula regarding the X-ray output, and it is approximately true that the X-ray output is proportional to the power of the KVP. So the value of A is about 2, depending on the specific tube. So this is what we'll end up using. Now I believe there is. Okay. Now, having said that, this X-ray output, while it is referring to this particular formula, is also referring here to the MAs. Now, the second part, or the second exposure, is changing from 0.5 seconds to 0.2, but we're leaving the KVP the same. So since we're leaving the KVP the same, this is what's going to change. So the question becomes, what are we going to be able to do in order to be able to generate the same X-ray output? And what we need to do is use this particular formula right here. So originally, what we had, pardon me, as soon as I can find my pen, there we go. Let's go back to what the question was asking. You had 100 MA times 0.5. So if I go here and activate the tool, I had 100 MA multiplied by 0.5. And that being the case, then that means we end up with 50 MAS. So now the question becomes, if we change the time to 0.2, what sort of MA should be chosen in order to keep the image darkness the same? In other words, our output is going to end up being roughly the same. So according to the, let's see if I can get this to not roll with me. Okay. So the answer here is telling us that it is 250. Now, how did we come up with that? Well, here's how we do it. We know that we're going to end up with 50 MAS because we want the output to be the same. So in order to be able to do that with the new value that we have, then we're going to have the X number of MA, which we don't know. And we're going to take that and multiply it by the time, which is 0.2 seconds. And when you do that, basically that means X, in this case, the number of MAs, is going to end up being, as soon as I can get this here, is going to be 50. And I don't know why it loses the focus like that. That shouldn't be happening. 50 MAS divided by 0.2. Now, if we weren't keeping the basically the mass the same, then this would become a much harder problem. But now we're taking 50 and we're dividing it by 0.2, and that means we end up with 250 MA. So that's how you work that particular problem. So let me clear this out. And again, it's all about keeping the output the same. Basically, it's giving the patient much less of a chance to actually move around and cause blurring of the image. So chapter 4, question 9. Diagnostic X-ray tube is running at 80 kVp and 10 MAS. The tube voltage is increased to 100 kVp. Approximately what should the new MAS be to keep the output the same? And again, we're going to use formula that we had here, which is this. And we want the output to be about the same. So in order for that to be about the same, we'd want this number to be about the same. So let's see if I can get the pen to not totally collapse. Let's see. Let me do this. Let's try this. Okay. All right. So we would have, and I'm going to try to keep that formula over there, 80. That's the 80 kVp squared. So we take that and we square it and multiply it by 10. That result ends up being 80 squared should be 6,400 multiplied by 10. which ends up being 64,000. Now, this is KVP times MAS. So what we want is to keep this output the same, but we want to increase the tube voltage to 100. So we're going to start out here. We want this output to be the same. And we're now going to change the KVP to 100. And that's going to get multiplied by, and I'm just going to, he's a bad choice. I'm just going to call this Y. I don't know what this value is, but I'm going to figure it out. Y works. Y is going to be equal to 64 divided by 100 squared, which ends up being 10,000, which you apparently here having significant issues with. So we take this, divided by that. So how many times does this go into there? It should be 6.4. And let's check and make sure that I'm not stirring you wrong. I don't want to do that. 6.4. So that's the answer in MAS is 6.4. So this is how you work the problems here in the chapter 4 homework. Hopefully that's once you see that it's not quite so intimidating.